a lot of our meetings. We do have a Slack, and then we try to record all these and post them on our YouTube channel. As always, here's a list of our organizers. If you have any questions, comments, concerns, feel free to reach out to any of us, and we'll do our best to address those or connect you with somebody who can. It's a lot of free training out there, so feel free to check those out if you want to learn a little more about Azure. Today will be a talk about adding some chaos to your pipeline, so they'll be virtual by Mike. And then on the 31st, we'll be having another virtual application gateway versus traffic manager versus front door by Tony. We will be looking, I believe, in July for our next in-person event. So keep an eye out for that. Otherwise, the next couple are going to be virtual here. And that one will be hosted by one of our sponsors, Lean Techniques, at their office. So keep an eye out for that. For the short term, going to be some more virtual ones, and keep on keeping on. And just say thank you to our sponsors. And with that, I will hand it over to you, Mike.
Great. Thanks, Alec. Let me go ahead and share my screen. Nice we mean about Teams being slow. Wow, that was really slow.
Yeah, a lot of times when I get my camera on, it really bogs it down.
All right, is my slide deck showing?
Yep.
Yes.
Looks like that's the red border there. All right, yeah. Thanks everybody. Thanks a lot for having me out for you guys' virtual meetup. Excited to be talking here today, and excited to be talking about some chaos in your pipeline. So just to quick introduction, my name is Mike Douglas. I'm a solution consultant and the director of our delivery engineering group at Lenavi. Lenavi, we're a consulting company that helps organizations with their basically end-to-end IT needs, from DevOps to custom IT, cloud, and managed services and hosting. So I'm Microsoft MVP in the area of Azure DevOps. So I got to kind of slide in a little bit about a pipeline there to everything's got to be through a pipeline. Do some volunteering around, charge of the Omaha DevOps meetup. It's been a little quiet there, but trying to get that back going again, and do some other things, including like run a robotics club for 4th to 8th graders, which is a lot of fun there. So, and then there's my Twitter handle. If there's everyone reach out to me, you can do that, or my email address. All right. This is a topic I actually really like. I'm probably one of those weird people that tend to like the non-functional requirements almost better than the functional requirements when building a system there. We're going to be touching on a couple of these today, kind of resiliency and availability with the Azure Chaos Studio. And we'll talk a lot more about what that is here in a few minutes. And then another big non-functional requirements around performance, and with the Azure load testing service. These are two brand new services. I think they're still both in preview, but pretty exciting capabilities that you have to incorporate these into your pipeline and cause a little chaos to what's traditionally been pretty stable. So just kind of a why we need this. So looking back real quick on our pipelines, traditionally, we've added pipelines to really help make our applications deploy, more smoothly, more effectively. We've shrunk down the batch sizes. We've deployed them more frequently. Basically the thing is to minimize change and get everything to go out there smoother. A small change is easier to deploy than a big change. So we're trying to just manage small changes out to production, so kind of minimize differences in there. So and then we can even improve our quality by running our functional tests. But how comfortable are you if something goes wrong with your application from if something from a non-functional perspective happens? What if there's something unexpected? Will your application still work? Maybe all of a sudden double the users comes across, or there's a failure of maybe one of your services or a VM. Or in the unique, hopefully this will never happen again, cloud region failure. If the whole region goes down, what will your app actually work there? Will it maybe degrade to something less than ideal, but still functional? And I think a lot of times we think it does, but like, how do we know for sure? That's kind of what I want to show here in the next little bit of time to show kind of how that works. So before I kind of jump into this, I just want to talk about resiliency, and because it took me a little bit to kind of like figure out, okay, what exactly is resiliency? And first of all, it was like, okay, I want to prevent failures. So if there's a NIC card on a machine, like I want to make sure that NIC card doesn't fail. Well, unfortunately, we can't. Even with Azure in the cloud, there's underlying infrastructure, physical infrastructure that will eventually start to fail. So we can't prevent failure. So that's not what really resiliency is. But can we prevent the outages when there is a failure? And that's really what resiliency is about. And it's about keeping the application running, or whatever you have running, without the failures. So it's to basically recover and continue functioning, and really avoid any kind of downtime or data loss. So that's what we're really talking about when we're talking about resiliency there. So then kind of now when we look at Azure and resiliency, I imagine this group knows quite a bit about all the resiliency in Azure, but it has become very good at becoming resilient. Lots of capabilities and tools. We've got monitor learning, security and scale. A lot of things are as easy as just checkbox, right? We can, even if we create an app service and like a PaaS service, we can enable availability zones with pretty much just a checkbox. So there's a lot of stuff built in. We can do things more directly through like our IaaS, availability sets and zones and region pairs, and their PaaS services with some of the more advanced features of like premium SKUs. So a lot of capability to make your application more resilient. However, is your app resilient? And how do you know it's resilient? Like, have you ever really tested it and actually like turn something off and make sure it still works? One of the things we've traditionally done in projects, if you haven't done this before, I think this is really always a good thing, is to kind of go through, and we do this in like our sprint 0 part of our project, is to go through a failure mode analysis, which will, you go through and identify like what are the different, what could fail in your application, and like how to detect it, what's the likelihood that it'll happen, and kind of how to mitigate or remediate those types of things. So you can kind of go through that process with that. So that's very manual, right? That's not as fun as what we want to talk about here in kind of Azure and DevOps kind of topic here. So we're so that's where chaos really comes into play. And so if you haven't heard of chaos engineering, imagine maybe some of you have, since you've joined today, or either interested in what it is, or maybe you do know what it is. But really it's about intentionally breaking your app, or trying to break your application by injecting like faults or failures into your system, and then make sure that you can still have it running. You're probably like, well, all we do is try to make sure everything's up and running. Why do we want to try to break it? Well, because things will fail, and so we need to make sure it works. So it's better, I think, to test those things and have us kind of in control instead of just waiting for fate to happen. And then the other thing too is, remember, the faults and the failures should not equal the outages of the system. Sure, everybody's familiar with the Simian Army of Netflix, and in particular their tool called Chaos Monkey. This tool kind of made this popular. Gosh, it's actually been quite a few years ago, probably 8 or 9 even now, where they did this exact thing, and they even do it in production. So those buffering signs you get from Netflix, it might not be your internet connection, it might be their Chaos Monkey and Simian Army doing that. So that's that. So that's been doing that there. So now what we have in Azure is a tool to actually do that same type of thing, have that same type of Chaos Monkey capabilities to try to break our systems. And that's what we'll be showing here in the next few minutes. So what is Chaos Studio? It's really a way to create experiments to test for the resiliency. And it's made up of several things. The experiment is kind of like our main piece there. That's really the steps of everything that we're going to do to try to break our application. It's going to run for a small period of time. And then we'll be able to check to see if our application is still running. Targets are those resources in Azure that we're actually going to be basically issuing faults and failures against. We have a thing called selectors, which is a way to select multiple or group different resources together. Maybe we want all the application gateways for the dev environment. We could create a selector to bring all those in and test all those at the same time. So we're not having to like do select this resource and this resource and this resource. So it's kind of nice there. Our fault actions are what we're actually going to do the failures. So let's dig into the fault actions a little bit more in detail here. So again, this is what we're going to do to verify our system kind of handles those disruptions. There's different kinds of faults. Destructive is, basically just, turning something off or deleting something. How does your application run there? We'll actually do that one because that's the most fun out of all these. Applying pressure, like if we want to run CPU threshold at 90% and see how your application runs. Azure Chaos Studio can basically turn on Google Chrome for your machine and it'll run at 95%. No, I'm just kidding. The latency, like how, it runs great if you're connected with your high-speed internet connection, but maybe not if you're mobile. You can test that. And then also configuration changes, right? Not something you typically think of as a fault, but a lot of times somebody makes the wrong change that's going to break the app. And it's good to kind of see what that does. And maybe we don't want a single point of failure of any one configuration changes. Any questions so far? I'm running through this pretty fast. Just want to make sure I get to the demos and stuff. But yeah, if you have questions, please feel free to just jump right in and ask, but I'll leave time at the end too for questions.
Or you can put them in the chat window and I'll watch the window.
Oh yeah, perfect. Thanks. Yep. So, all right. So those are kind of different types. You can see in addition to that, the faults are kind of in different categories. So there's some that can go directly against the services themselves, which is kind of ideal if you think of it like agentless. It can go right at the ARM API and do the actual faults. But then there's also ones that require an agent. You can think about a lot of these as ones that have to run on a VM, right? So if you need to do like a kill process or something like that, it's you basically, there's a chaos agent that gets installed and then it can actually perform these activities and do the things you want to. And then there's also other platforms, right? And they'll keep expanding this out. So this is in preview. You can't create your own fault types right now. I think it is on the actual backlog that they're working on. So right now we're kind of limited to what these provide. But what's nice too is like this AKS Chaos Mesh. Chaos Mesh is actually a like open source tool already for doing chaos type tests on Kubernetes. So instead of like Microsoft and Azure Chaos Studio kind of creating their own process of doing this, they leverage this open source tool already. That's kind of an industry standard for that, which is really nice. And that's actually the one we're going to show and go from there. So, all right. So then the last kind of part of this before we kind of jump into the demo is, like we talked about, like we want to still make sure it's running, but what does that actually mean? And I think that's the part where I think the tool still doesn't really have something. And that's where, kind of the second part of the demo kind of comes in. But how do you know if your app is still running? There's different ways. Well, first, there's different meanings of that, right? Is it functioning properly? And this kind of depends on how the application is architected. And so if you're talking about a resilient application, you may lose some functionality of the app that's not critical, but the app could still be running. So that could, still be considered running. We worked with an energy company that they kind of had blue sky and gray sky mode, and we helped with this outage app. And so when there was an outage, it kind of switched over to this gray mode. So it could support up to their like 5 or 6 million users. But it had reduced functionality, but it allowed people to still submit their outages and not give them any kind of like failure screens. So that was kind of a introduced one, but could be triggered automatically too. But that kind of thing can be triggered in there. But then how do we verify this? And so there's different things that we can use. One, in Azure, we can use availability tests, which are essentially like a ping test, or you can make a little bit more advanced ones too. But in general, those are just kind of checking it every so often. But most of them, you get back to 200, it's working. That may still not show exactly the failure there. We could use automated tests like Selenium tests to do that, or RPA, robotic process automation. Very similar, simulating user interactions with the application to make sure it's always running. Or the third one is using some sort of like load testing service to make sure that it's still working. Because it's not just one user we need it to work for. Like just because we have an outage doesn't mean our user count's going to go down. We're still going to have the same usage of our application, or it could even go up. So we need to make sure it still performs under test. So that's why we're going to do a kind of chaos demo. We'll talk about load testing service, and then we're going to put them together and really cause some chaos from that. All right, so let's do this and show you how to create this test here in Azure Chaos Studio. So let's flip over, and just for fun, my Visual Studio subscription ran out of credits, and so I recreated everything. Yeah, so we're coming in a little hot on this, but it'll be fun. So Chaos Studio is not like a resource you create. Chaos Studio is basically a service, more like Azure Monitor, that you then create resources around. So in this case, a lot of times you just come search for Chaos Studio, run that, and then you can come in here and set this up. It's really made up of two things, like we talked about. One is the targets. So the first thing that we have to do is enable our application that we wanted to use to run in there. And that's really good because you really don't want somebody to, trying to have a little too much fun with this, start hitting some of the services out in production and things like that, and be like, hey, I was just testing it, and everything goes down there. So you have to actually enable it. And you can see here, I've already come in and enabled my AKS cluster to actually be enabled for this. And it's really nothing more than, I'll just show, you come here, enable it, and then enable that service, and then it will complete that. And I think it'll do it right here with the, well, actually it doesn't show anymore, but it'll complete that connection there. And then that's the primary thing that you have to do. Then we create the experiment. We'll go ahead and create that. I've got a couple of these from previous demos that I did. We'll go create the demo here, create it here in the subscription. Let's create it in the resource group that I had the other one. And then we'll just call it the demo for like kill pods. Then we can create we want to run that. Then it brings up the resource designer. So it looks a lot like the screenshot I showed there. We do have the kind of steps that we want to do, and you can have different branches. We're just creating a pretty simple test here. We're going to, kill the pods. We'll do the same thing here, kill pods for the branch, because we could have different steps there. We had our action, so this is where we can do add our faults. And so this will give us a list of all those different faults that we talked about in that one list. And in this case, we want to use the AKS chaos mesh pod chaos there. We can set the duration that we want this to run. Anytime we run in a demo, it always feels a lot longer than we run it there. And then the other thing is this JSON spec. So this uses like a YAML file to kind of specify how we want this to run. And then you have to essentially convert that YAML file to JSON. And this, again, is part of the chaos mesh. It's what they use. But because ARM is JSON, we have to convert their YAML spec to a JSON spec. In this case, it's pretty straightforward here. We're just basically I'm just running against the default namespace, and then it's going to run for 60 seconds, and then this failure mode for that. So nothing too fancy there. We'll go ahead and run this. You specify what you actually want to run this under. We'll go ahead and add it, or which target, I mean. And again, that only shows the ones that were enabled. And then the last thing is here, we'll go ahead and create this. And then just like anything else against the deployment there, we'll create that. We don't really need to go in here and create it. The last thing we need to do is this actually creates like a service principal kind of behind it to run this. So what we have to do is we have to go enable that service principal in our AKS cluster. So I'm just going to come over here. I'm going to come to the access control. And then role assignments. We'll add a role assignment. And then we'll just use the AKS cluster admin role. And then we'll go ahead and add what we just created there, what do I call it, kill pods. That was kill. Let's look. I think that was the other one. Okay. Oh, here, demo kill pods. There we go. So this is that account that we created on there. Select, assign, and create. There, it's going to add that as a role. All right, so then now let's go back to our Chaos Studio. Not run this one yet. What I'm going to do is actually to kind of see it working. We're just going to list out the pods. We'll see them running and see that we don't have any restarts. So what we should see is that these pods start getting restarted because, you know, this experiment is killing our pods, but we need to make sure our application's still running. So we're hoping Kubernetes will bring back our pods as they start to fail. So that's what Kubernetes is supposed to do, right? So let's go in and actually start that. And then if we come back over here, we should start to see, and there you go, it starts to, the pods are starting to be restarted. And you can see that the pods are still working. It's not super exciting demo, but at least we can see a little bit of action. It's random, so it's not going to be the same every time we do this. I'd expect a couple more maybe. I guess I did shrink down the time, but it should still be running. And we should get some more pods kind of filling here in a second. But that'll essentially run out. I think I just set it for like 30 seconds, so it's not going to be real long in what it runs. But at least I guess at least we saw one restart in this demo. But this was kind of showing us that the application's running. So we could be going out and actually in this case, it's just an API call. So you can see it is still running fine, even though the pods are, you know, causing it to fail, which is what we'd expect. Whoops. Oh, there we go. We got a few more failures there, but again, our application's running. But this isn't a very great way to test this application, right? We want a better way. So that's what we're going to talk about next. I guess any questions before I move on next to the load testing service? Any questions at all in the chat about Chaos Studio? We'll come back to this again, and we'll do the grand demo, I guess, for typing it up way too much. All right, so let's go into the next part here. So now we're going to talk about the load testing service. So if you've not done load testing before, there's different types of load testing. I'm just going to kind of move through this kind of quickly here because I don't want to spend too much time. The main things are those like, you know, capacity is going to, you know, be our expected capacity to make sure things are running. Stress is going to try to break our load test here. And a soak test is basically something that runs for a really long time and tries to see if there's something like a memory leak or something like that. Most of these other tests I usually run within just a few minutes. So those are kind of, in our case, we're just going to talk about more of a general load test that isn't necessarily at our capacity, but it's more than just a single user. We want to make sure it runs. And surprisingly, a lot of things, I've caught a lot of things breaking just with simple load test. So the load testing service itself is pretty nice. They've actually had a couple versions of, or not a couple, but they've had one other version of this that was tied to, I don't want to say Azure DevOps, because I don't know if it was actually Azure DevOps still when it was there, but Visual Studio Online, maybe it was there. It was more tied to that. And then it was more tied with the load testing tool inside Visual Studio. That's gone away. That's been deprecated. I think even removed out of 2022 Visual Studio. And now Microsoft is really just, I mean, they haven't really landed on any one thing, but like this is using JMeter, which JMeter is a pretty popular open source tool for doing load tests. It's an Apache client tool. Here, I actually can show you real quick to see if you've never used JMeter. Basically, it's a UI for creating the test. You can see we're calling that same API endpoint against our running IP address, and then we'll you can set like the number of users here, like 50, and then run those tests and do either command line or do it through a tool like the Azure load testing service. This is also made up of test engines, and the test engines, think of those are the VMs that the tests are going to run into. So if you've done limited load testing or haven't done it before, a lot of times you start by doing the load test from your machine. Well, that only works so far. Like you'll only be able to test maybe 200, maybe 500, depends on your test. And then you'll actually start load testing your machine because it can't handle any more requests that it's trying to send out. And so that's where you really need to have some sort of like test rig like this, that we can have multiple agents and test many more there. So we could scale out to thousands or tens of thousands or even more if we might need it to do it here through the test engine itself. So then the interesting part is we have the client statistics. So that's pretty typical. Like if you run it in JMeter and any other tool, you get back like your average response time and how many requests per second you did. Those are great, but you want to have non-functional requirements that say, oh yeah, it has to be within 3 seconds or something like that. But you don't really know if your application is at its max with that current load that you're running, or could it handle triple or 10 times as much, because you can't really see the server side when you're running those tests. You just see what you're getting on the client, and you hope that you're not seeing a slowdown. That's where this really shines, and I think this is where I think it's the most interesting, is because we're running our applications in Azure. We can actually add those Azure components to our load test, and it will actually bring those in as server-side metrics. So we can see the CPU usage of our app service. We can see all of our Kubernetes, we can see Kubernetes metrics, App Insights metrics, all kinds of different ones. And it'll be perfectly correlated with how our test's running. So if we do see a slowdown, we can see which service is actually causing the bottleneck. Is it SQL Server? Is it our app service? And so that's pretty cool that it does that. We'll show that here right now. All right, so let's go in. You kind of showed already a little bit the load test that we're going to do. So we're going to basically take this test that we've created, and then we're going to run it. So let's go down. Let's switch back to Azure and show what our Azure load test looks like. So actually, let's come over here. So the Azure load test service is actually a service unlike the Chaos Studios. This is something that you'll actually provision. There's a flat fee. I think it's like $10 a month, and I don't remember where the cost is actually. Just have to put in here. Azure load testing there, and then they'll charge for the consumption. You know, if you created 10 tests, it's not going to be the same cost as if you create one for, you know, 100,000 users. There's really not much to this. You specify the resource group, the name, the location that it's in, whether or not what kind of encryption you want to use, and that's it. And then you create the service. I won't go through this. We'll just look at one that I just created. And then here you come in. It's interesting is this is one of those services where it's going to be like users that are not just the admins, like the portal admins. So what it actually has is its own set of permissions that you have to grant within the tool. And so there's like a load testing owner, load testing user, load testing reader. I guess not gonna run for me right here, but you can see there's these different load test roles that you would add users. So it might be like your test team or your QA team that you add into this, which may have never even used Azure before. Now they'll be able to actually just use this one piece of Azure and still do the functionality or do the functions that they need to do. So once we come in here, we'll actually create a test. You can see there is my weather forecast test that I've already created. We'll just create another test. And we can just call this demo, and then we'll just create it right after. Our test plane is really our file. So in this case, here, let's see here. Yeah, I think my security guy made me delete JMeter a couple months ago. This is the J for log. Let me just come over here, get the all right. So now if we come in to here, I'm just going to specify the same test that we're running there. That's this JMX file. That's essentially the same one here that I've opened. It's just, you can see it's the same exact path. So go ahead and open up that, upload it. So now we have the test here. We can, if we parameterize this test, we could do some more things, like maybe we have like the URL if we're going against dev tester prod or something like that. We can come here, we can specify how many engines we need to. So each engine can do, I don't know what it says, 250 maybe, or a little bit more. So in this case, I just need one. I'm only doing 50. What's nice too is you can have some different metrics and conditions. So if you have a request to say, like the response time average, you know, if it's greater than 5 milliseconds, well, actually, it probably will be greater than 5 milliseconds. Let's do 5,000 milliseconds. Then that will actually, it'll actually show failure for that. So we'll go ahead and create that. Fun. Nothing like a live demo where there's a thunderstorm out here. So we'll create this test, and it's actually going to kick off the test right away. And what I wanted to show over here was this is App Insights. And so this is kind of a fun way to see like what it's doing. If I configured the pods right, we should see this scale up. But there's always a chance I didn't do that. Exactly right there. But the idea here is once this starts running, I think it only has 50 users, so it's probably not a major stress test on this. But if what this would do is because I have my pods set using the horizontal pod autoscaler, this would, and you can see now here, you're starting to see the requests. We'll start to see the CPU percentages come up here. And if Kubernetes sees these go high enough, we'll actually add more pods. So let's see if we do that. If not, we'll make sure our next test, we'll bump that up. So it looks like it's handling that load because it's just 50 users. But you can see here running and a few of the other kind of CPU pieces there. We only have 2 servers online. So not super exciting demo, but we'll bump that up here in just a second because that makes it more fun. All right, well, that's the kind of load test demo there. We'll come back over to this test run. You can see we're starting to get some of the client side metrics. Oh yeah, I forgot to add the server side ones. We'll do that here in just a second. But yeah, you can essentially configure the app components to this. Well, let's not do it at the test run level. I want to do it. At the actual test. So let's come back here. I think if we come in here to this test run, we can configure our app components. So maybe I should look at my demo script a little more often. But we'll add here, we'll add app insights. Oops, that's not the right app insights. And then I think that's probably, I guess we can add that. I'm not sure if that'll bring in anything. I don't really need to see the Cloud Shell. So I think that's the main components that I just added. And so we'll add those. You can see it pulled in the, it goes for all 5 minutes. I should have made that go shorter time. Oh, this was one from earlier. Oops. Well, that's all right. That's going to be the more exciting one anyway. I don't know if it'll go back and add the results. See if I can add this in, see if it'll correlate it. Oh yeah, perfect. So even though I ran this earlier today, you can see about an hour ago, here I can see, you know, the pods and the ready status, failed requests. There weren't really any. I mean, this wasn't like a huge test, and then percentage of CPU, you can see it went up to 30%. But you can see how it correlates essentially the client side metrics along with these client ones. You can see here, it was response time was fairly regular. It jumped up to the 50 users pretty fast and stayed consistent there. And then the requests were pretty consistent. So it handled this no problem, which I would sure hope so. 50 users calling a mock weather forecast API, it should be twilight's thumbs. So yeah, any questions at all? We'll kind of jump into the last section here. All right, so let's switch over to the last section, and I just kind of want to make sure to leave enough time for questions at the end. So how does this fit into pipelines? So we basically showed manually creating the Azure load testing service and manually testing the Chaos Studio experiment. You know, I think the question is how long, and you know, we have, you know, pipelines today are, you know, with every application pipeline or nightly or weekly before release. Traditionally, load testing has always come at the end of a project. Chaos Studio, I imagine people would probably think of it at the end again too. Problem is with that is if you know, doing it at the end, if you find something, it's really too late to do anything about it. And that's where I really like to push this stuff forward and be doing this continually through your project lifecycle as you go. So, you know, it's like, it's much easier to fix and keep it in the like right levels than try to have to go fix it at the end. So with that, you know, there's the application pipelines, you know, that's really, we have our application centric infrastructure, could be like a microservice or maybe our static front end. You know, we want to keep those pipelines really fast. I always say try to keep it under 20 minutes to go from dev to prod. Obviously, a lot of places need gates, you know, on there to have it. But if you if you think about it, just like pushing the approve at every gate, how fast could you get it from basic dev to all the way to the end? So, and that's where I think what makes more sense to me is to probably have a separate pipeline to where you keep your chaos and load testing it. Oh, hold on 1 second. My dog's freaking out about the storm happening. Come on. Always fun, right? All right. So then load testing only pipeline. And what I think kind of makes sense, and it just really depends on how active and how risky are changes being made to know whether or not to do it daily or weekly. But I would say weekly at the longest to go in there, because if you with load test, if you run it once and you get like 4 seconds, let's just say, you don't know if that's the right time or if there was something going on that may have affected it. But if you run that same test multiple times and you get the same amount, your confidence level in that test and those results goes up. So that's why I like to run these more consistently and weekly, and then having the developers add the load tests as they go throughout the project to do that there. And so that becomes the best fit. A lot of times you create separate environments get created for the load testing and stuff. I'd say don't create a separate environment. Have it right alongside your testers. They shouldn't see an impact. If we're assuming we're not trying to like crash it. If we're trying to run load tests to do stress testing, which I don't do that often, just run it in the same environment, and everything should play nice together. And again, you can get the confidence to even run these in production when it makes sense. All right, so what does that look like then? So we got good and bad. Well, not good and bad, but we have good and even better. So so when we're talking about pipelines here, we kind of have two separate pipelines. So in this case, so I'm using the YAML pipelines in Azure DevOps. And what's nice is for load testing, we actually have a built-in task. Let me zoom in a little bit on that for actually running the test. And it's really nice because you just specify the subscription you want to run it in. We specify not the JMX file that we're doing, because if you think back to, let's see if I still have it open here, but the load testing, this is Kubernetes. Here it is, the load testing over here. So if you think about like all of the load testing settings that we wanted to, I guess I'm not going to see, like all these settings here, like we want to be able to do these same settings without going through the portal. And so that's where, sorry, trying not to click too many times. That's where this YAML file comes into play. And that's actually what can manage that there. We're just specifying the resource group and then the load testing resource. And then the other side of it is the, I just noticed this Azure subscription's not quite right. So it worked earlier, but let's just make sure this is correct. Again, this was my switching from one MSDN account to a Visual Studio subscription to another one. But unfortunately with the Chaos Studio, there's not a built-in task in Azure DevOps to do this. They do have a demo, which I hadn't noticed before, maybe they just added it, where they show how to do it with like a logic app to kick it off. But what I found is you can actually use the REST API to do it. So I'm using a Azure CLI task, just running basically a bash command, specifying the subscription, the resource group, and then my experiment name. And then I can call the REST API to actually kick that off. So it kind of does a fire and forget on this, which is fine because I want it to go on to this next task anyway. And then it will run the load test here and commit that. So let's do this all from just a branch. So that's fine. Here's the other files. So that we were just looking at the YAML file for the pipeline. The other thing I mentioned is the YAML test here is basically the same thing that we were just looking at, right? So we specified that we want to run one engine, and then we want to do it for the test there. So let's just bump this up. So I'm going to go ahead and edit this real quick. And instead of 5, we'll do 500. I just have to be careful. This subscription, if I go over, I have to start paying. But still have some credits in there, so it should be fine. So okay, so then we have the test ready, 500 users. We have the pipeline ready to run the full test. And then, yeah, let's go. So let's go over here to the pipelines. That's probably kicked off, maybe because it was in the wrong branch. So we're going to run this from my test branch. Ooh. See, it's a real demo. Based on the change I just made. Let's take a look. Oh, I probably forgot the take. Or no, I did have the tick on there. Interesting. That all looks right to me.
Do you have to do any sort of special syntax for your JSON, your subbing in values down below? Do you need to do the ticks and the brackets? I don't know.
No, the bash is pretty forgiving there. And that should work okay. That's interesting. Don't know. What did I change? Well, I guess I could. And that looks pretty simple. Well, I guess let's I can't. Let's put this back. I'm not sure. Be okay because I have access to both. Because I'm pretty sure it worked before. And then we'll see. Whoops. Started clicking too much. Chaos. Oops. All right, so we'll see. Hopefully that takes now. Back here to the pipeline. I clicked too much. Come on. Oh. So apparently it did not like something I put in there. So let's just take the one I did. And so I can rerun that. No. Well, that is, bummer. I guess I shouldn't have made that one change in there. Parsing didn't find the expected key. It's usually like a space or line 19. Let's see, 8 minutes left. Plenty of time. Well, you know, what's space? Have I told you how fun YAML is? Whole nother. All right, so let's see if we're good now. It's lined up, inputs lined up. All right. Okay, so we'll see what happens here. Apparently I didn't run this before. People are coming in right for the finale.
I was gonna say, if worst case, it looks like it might be working. Worst case, you could also give it the commit hash of your last one to run on that branch.
Yeah. All right, so we're good there. With let's see, so that should have kicked off the chaos. So if we come here to our experiment, we should see one running. Maybe. My internet. Are you serious? Let's see. Is it this one that we? This is one. There we go. So that's running. If we come back here to our pipeline, there's running our load test. So if we come here to our AI, look at that, perfect timing. So there now it's our memory just spiked. Looks like we're not even seeing those requests coming in. I really think my whole internet connection just slowed really down. This thing should be lit up like Christmas. Come on. So if we looked at our load test, it should also be running. And then this should be terminating more of these. You can see additional restarts. So chaos is running. Our load test should be running. It's executing, so that's all good there. And now, okay, good there. It's running a little bit there. And we've got our horizontal pod auto scaler scaling out, so that's cool. We're seeing the additional pods being created. You can see now we're up to 4 servers there. Again, we're not a huge load. But yeah, wow, got that all kind of pieced together at the last second there. But you can see now the incoming requests are gone up quite a bit now. So this probably means our additional pods are up and running. So now it can handle kind of double the load. And you can see some of the CPU averages went down, but now it's come back up because it can handle that. And yeah, should be pretty good there. So if we come over, I think this run, let's see if it shows us our server side metrics for now. Yeah, so we're actually showing those. No failures, which is good. I don't think we have any failures up here. So there's our 500 virtual users. You can see our requests per second coming in. But really, you know, we're looking at 12,000. Goes hand in hand with what we were seeing here, you know, somewhere between 10 and 15 requests. So it's kind of cool seeing the different usage there. And I think I had this, so it'd go up to 10 if I remember right. So clearly, and it's staying under the 50, so that's probably why it hasn't needed to expand there. And there, so we have just a couple minutes left. We can kind of run this out, but any questions at all? This is really what I wanted to show here, kind of seeing all those kind of pieces together. This will run out, but you won't really see anything different with that. So, but if there's any questions, let me know. Otherwise, I'll stop sharing.
Thank you for your presentation. Derek, can you want to kick off the recording in case anybody wants to ask questions not on recording?